Unit 2. We are doing still equations. Day 8. Someone help me.
I think so, yeah.
I think it's day 8 too. Yeah? Thank you, Megan. Today we are doing variables on both sides. Steps are going to stay the same. We're just going to try to confuse you a little bit. Quiz on Wednesday. Test on the chapter probably next Thursday or Friday. I say chapter, I mean unit. Because we're finishing up equations. We'll finish up equations probably by Friday. Then we've got to do some inequalities. Inequalities are with those gator mouths. And then we'll go from there. Okay? We are going to have, so this anchor chart is going to get a little added to it. Okay? So we're just going to start with the anchor chart with the rules again, and we're going to go from there. So you have most of these steps already written down, but I would have them again. Solve any equation. I would say 93% of the time, for all equations, I'm talking algebra 2, calculus, you'll be able to use these steps and still solve the equation. I'd say 99.9% of the time for our equations, you're going to be able to use these steps. Okay? So, step 1 will stay the same. Find the balance point. Always, always, always. Where is that balance point have to be, Evan?
Balance point has to be where the equal sign is.
Yeah, where the equal sign is. That equal sign is telling me this side equals the other side. So even if there's a bunch more stuff on my left-hand side than my right, I know that this bunch of stuff will still equal the one or more things on this right-hand side. It's never going to be cockeyed. Everybody with me? Okay. Number 2. Distribute on one side, and then I'm going to put if needed. So we're only focusing on one side. So we're distributing on one side if needed. Still with me there? Okay, so we're still focusing on just that one side. Step 3. On that same side, combine like terms if needed. Okay, does everybody understand when I say on that same side? So if we start with the left side, stay on that left side, do everything that you possibly can. Step 4. Repeat. Steps 2 and 3 for the other side. Okay? And those steps are distribute and combine like terms. Okay, so we're going to stop there for a second. Everything about these equations are simple there. We've got a left side that we're going to distribute and combine like terms. We've got a right side that we're going to distribute and combine like terms. Don't try to do the whole problem at once. That's why we split it. It's going to make it easier if you cover up half of it and just try to finish and simplify, not solve, but simplify as much of the problem as possible. Step 5. Here's where we get the important step. Combine like terms on opposite sides using inverse operations. We're going to add a couple caveats to step 5. So here's little thing first. Start by combining like variables. Always move the smaller variable. This is the huge new part. So we're going to start by combining variables. So if there are variables on both sides, you're going to see this in an example. Start by combining the variables. Okay, so if I've got a 3x on one side and a 5x on the other side, combine those first. But they're still on opposite sides, so we're going to be using inverse operations. When doing this, the inverses are always add and subtract. Okay, always add and subtract. Just can you keep your head up, please? Thank you. Okay, we always add and subtract. So, we're going to combine the variables, but does that mean we don't combine the other terms? Because we've been doing that already. So, what do I mean by that? You don't have to copy this down, but if I have 3x plus 5 equals, 14, combining like terms on opposite sides, I would combine this 5 with the 14 by doing the inverse, right? So we still have to do that. These are just specific steps on what to do with the variables. The last step is still the same. 6 is still the same by isolate the variable. So you need to have these copied down. These. I mean, these are critically important. And these will stay up there. Okay, so now we're going to, instead of use the two-step equations, we're going to take this away, and we're going to have that one. They're the same rules, just a little bit added. That's all. Questions on these steps yet? So let's see some examples. And my first example is the example that I actually showed Mrs. Armstrong this morning and said, hey, here's how I'm going to start teaching this today because I want to make sure that you guys have one specific way to do it. 5x plus 2 equals 7x minus 2. Let's make sure we can see that. Yeah, we're good. So I truly want to follow the steps pretty darn closely. Find the balance point. I'm now only worried about this side. Step 2 says distribute on one side if needed. Do I need to distribute over here? Brooklyn, how do I know I don't need to distribute over here? What are we missing? What's always shown. Need some help?
Yeah.
Carly?
Parentheses.
Yeah, there's no number smack dab up against the parentheses. That's how we know we need to distribute. So, nothing to distribute here. On that same side, combine like terms. Can I combine my 7x with the minus 2? No. So we're done with this side. Repeat steps 2 and 3 for the other side. Notice I'm really going to cover up this side again because I don't want it. I don't even want to be distracted by it. Is there distributing on this side? Bianca, how do I know there's no distributing on this side? Yeah, there's no number smack dab up against the parenthesis. Can I combine my 5x's with a 2? No. So we're done with 1, 2, 3, and 4. Step 5, combine like terms on opposite sides using inverse operations. Start by combining the variables. So now watch what I'm going to do. I've got a 5x, I've got a 7x. Does everybody understand that? Those are on opposite sides, yes? Okay. Always move the smaller variable. Mason, which number is smaller, my 5x's or my 7x's?
5x.
5x's. So when doing this, the inverses are add and subtract. So do I want to add 5x's or do I want to subtract 5x's to move this positive 5x to the other side? What do you think, Jackson? So 5x plus 5x is going to leave me with what on this side? If I said 5x plus 5x.
0. I mean, subtract.
Ah, subtract, because then it's going to equal 0. So I'm going to subtract 5x from this side and 5x's from this side. Still with me here? 5x minus 5x is 0x's on this side. 2 comes down. But if I took away 5x's from this, I take away 5x's from this. So now I have 2 equals 2x minus 2. Now I'm down to a single term with a variable. Circle it. What do I have to do to get that x by itself? How do I move this minus 2, Caleb? What's the inverse of minus 2?
Add 2.
Very good. Adding 2 to both sides. Negative 2 plus 2 is 0. That's the additive inverse. That's gone. 2x comes down. 2 plus 2 is 4. Still with me there? How do I isolate the x? Yes, ma'am. Go ahead.
Wouldn't that be subtraction though? 'Cause,
Where?
It's a positive to at all. Positive to at all.
You mean right here?
Yeah.
But because we're trying to get everything away from the x, I'm trying to get rid of this negative 2 from the side of the x. So we want 1x on this one side. So how do I move everything from that x? This is a minus 2, right?
Oh, wait.
We add to. Does that make sense?
Yeah.
And that's going to be a common problem. So listen, Maya said, why am I not subtracting 2? Because do we want to bring things to the same side as the x? No, we want to isolate it, which means gets it by itself. Move everything away from that x. Now what? Evan, what do I need to do here to get the x by itself now?
You need to you need to divide
By?
the 2.
Yeah, divide by 2 to both sides. 2 divided by 2 is 1. 1 what? 1x. 4 divided by 2 is 2. Not overly hard. The only difference was those variables. Okay? So we're going to do another one like that. Let's see what you guys can come up with. May I erase the words isolate the variable? We should have that, and if not, it's over here. We're good? Okay, give this one a try. Let's go. Negative 12x minus 4 equals negative 13. Actually, let's go negative 15x plus 18. So I'd like you to try that problem right now. Give it a try. Yep. Absolutely. Okay. So, follow the steps. Find your balance point. Again, as we keep getting tougher with these, because these are the basic ones, you want to have your left side and your right side. Can I distribute? B, is there anything to distribute on this side? Yes or no? You can take a guess. No. Good. Why not? Isabel, why is there no distributing on this side?
Because there's no parentheses.
No parentheses with a number smack dab up against it. Are there like terms? Brooklyn, can I combine this x with this 8? No. Okay. Cover up this side. David, is there distributing on this side? Why not? There's no number right up against parentheses. Are there any like terms, Alyssa? Can I combine my x with my -4? No. Okay. So we're good there. So now, combine like terms on opposite sides using inverse operations. Start by combining the like variables. So we've got this -12x, we've got this -15x. Always move the smaller variable. So again, think about your number line. Which number is farther to the left? -12 or -15? What do you think, Sammy? So -12 is farther to the left on that number line? So 0, -1, -2, -3, -4. Oh, -15. Think about it as degrees. Think about it as money. Which would you rather have? To lose $15 or lose $12? Well, I don't want to lose anything, but losing 15 is worse. Everybody with me? So this is my smaller one. Now, here's why we always move the smaller one. The inverse of -15, because again, we're always adding or subtracting. What's the opposite of the minus? The plus. So we're going to add 15x's to both sides. Watch what now happens to my variable. -12 plus 15 makes it positive 3x. -4 comes down. -15 plus 15, that's the additive inverse, that gives me 0. What happens to that positive 8? Good. It just comes on down. Once I only have one term with my variable, circle that one term. And we're still combining like terms on opposite sides. I've got a -4. What's the inverse of -4, Mason? What's the opposite of -4?
+4.
Very good. Add 4 to both sides. That's 0. 3x comes down, so additive inverse. 8 plus 4 is 12. Isolate the variable. 3 times x, so we have to divide. X equals 4. Fist if you got it right. Question? Yes, Haley.
I got it right, but I
Yeah.
accidentally did minus the 12.
So you added 12, which is fine. You can go either way. I'm just trying to give you an option where the variable will always be positive. It's not going to be wrong if you move the other variable, but I'm trying to limit your options so that you're not like, wait a minute, wait a minute, wait a minute. I don't know which one to move. I'm trying to tell you exactly which one to move first. Okay? Can we try it a little bit harder now? Okay? Hopefully we have these. If not, they're right over there. So I would call this a medium. Not quite hard yet, but it's medium. So here's example 3. Let's go 3x plus 4 minus 7x equals 5x minus, hold on. I just lost my train of thought. There we go. So, I'm going to give you about a minute and a half. I want you to go until you get stuck. See if you can try this problem and go until you get stuck, following the directions. So follow those steps, see what you come up with. Use that piece of paper. So cover up half of it, think, can I do anything to one side? Can I do anything to the other side? So I should see on everybody's paper at least that balance point. Okay, so pause right now. I'm seeing some things that are worrying me a little bit. Okay? And you know whose fault that is? It's mine. It's mine. I didn't explain it well enough. So let's go back. Let's take a stop for right now. Find the balance point. Mr. H, why is it important that we find the balance point? Maybe I've never described why it's important. Because when we find a left side and a right side of our equation, we are simplifying. We're not using inverse operations. We're not doing anything other than simplifying one side of the equation. And simplifying means just do what it says. Can I combine an x and a negative 23? No. There's no distributing. There's no combining on this side. We're done there. We are just simplifying this side. So from here, is there distributing? There's no distributing because there's no number with a parenthesis. Are there like terms?
Yep.
Yes. What are the like terms? Raise your hands. Gracie, what are the like terms? Good. 3x and a negative 7x. So now if I'm simplifying, notice, I covered that up. I want you to, if you have to cover it up with your hand, do it. If you have to cover it up with something, I would do that. 3x minus 7x leaves me with negative 4x's. What happens to my positive 4, Simone?
Comes down.
Comes down. Is there anything I can do to this side now? Is there anything else I can do? Can I combine an x and a 4? So now I'm going to draw my line and bring on everything else. Still with me here? Okay. Find your like variables. Swill, what are my like variables? 5x and negative 4x. So they're here. So I'm going to box those above. Which one's smaller, Maddie?
Smaller would be negative 4x.
Good. So now I'm using the inverse to take this negative 4x and put it to the other side. Remember, the inverse is always going to be add or subtract for these. So what am I going to do to this negative 4x? Go ahead.
You add the 4x to the 5x.
To itself and to the 5x. Because we want to get rid of it from one side. Negative 4x plus 4x is 0. That's isolating, or that's majority an additive inverse. So that's 0. This positive 4 comes down. 5 plus 4 is 9x's minus 23. Mr. Graham, can you put your head up, please? So now, circle your term with the x. What do we do from there? What are we trying to do now? Are we still combining like terms? Yeah, we still need to combine like terms, but what are my like terms? Is it the variables? Well, no, because we've only got one term with the variable. What about our constants? Yeah, so how do I move this negative 23 to the other side? Alyssa, how do I move a negative 23 to the other side?
Yeah, 23.
Very good. Additive inverse. I'm adding 23 to both sides. So that's 32, Mr. H. So negative 23 plus 23 is 0. 9x drops down. That gives me 27. Now we isolate the variable. We're almost done. Divide by 9. So x then equals 27 divided by 9 is 3. Show of hands with that fist. Who got these right? Okay. Hmm?
I did,
You subtracted 5x?
Yeah.
Did you get negative 9x? Okay. Did you get the right answer?
I got 3.
Good. You're still going to get the right answer. I'm just trying to get everybody to do it the same exact way. Okay, questions on this one? Let's try one more on your own. Call us over when you have it. So raise your hand once you have it so we can check it.
Call us over if you have a question. If you get to that point and you're stuck and you think, I don't know what to do next, raise your hand.
Okay. So give this one a try. Truly, truly, truly. Work on splitting it, covering up each side. Doesn't matter which side you start on. You can just choose. Just cover up one side and start on the other side. Nope. Hold on, gonna change something. Actually, try your best. See if you can get it. It might be a fraction. We'll see what happens. Try your best.
If you get to a spot and you are stuck, just give us a little head shake or something. Okay?
Good. Perfect. Not quite. What happened to 6? I forgot all about it. -6, you have to move that -6. You were in here, weren't you? You're close, but that's not how you divide. 2 divided by 10 is 5. 10 divided by 2 is 5. Okay. Here's good. There you go. Okay, so listen. It doesn't happen often. I am pretty perfect. I screwed up. Okay? I'm telling you, I screwed up, and that's my fault. Usually I've been trying to give you whole numbers. If you played the game on Friday, you saw some fractions, because I made them a little bit tougher. I did the mental math wrong. I was trying to get -10 on one side, +10 on the other, and I screwed up. Does that mean we couldn't solve it? No, a bunch of you did. I'm proud of that. So, if you're a little confused, you will not see this type of question on your quiz. But can we still solve it? Yes. So Let me choose this color. Find my balance point. Cover up half of the problem. Okay, that's going to be crucial because now you can see how to simplify. If I gave you this and said, okay, simplify it, most of you can. 3x's, positive 5x's gives me 8x's. -2 minus 4 gives me -6. Show of hands who had that on the one side. Okay, most of us had that on the one side. That was good. Okay, can I combine my 8x's and a -6? No, I can't combine my x's with a 6. So now I'm going to cover up this again. No distributing, but there are like terms. 5 minus 9 gives me -4 minus 2x. Does everybody agree with that? Who had that on that side? Yeah, okay. Take this away. Excuse me. So now the step says combine like terms on opposite sides using inverse operations. Start with the variables. -2x's, positive 8x's. Still with me? Which x is smaller, the -2x's or the 8x? The -2. The inverse, remember we're using adding and subtracting to move these variables. So if it's -2, we add 2x's to both sides. -2 plus 2 is 0. That's the additive inverse. -4 comes on down. 8 plus 2 is 10x's. -6. And this is where in my mental math I said, ooh, -4, -6, yay, it's going to be -10. And then I screwed up, I'm sorry. I screwed up, I'm sorry. So at this point, I want you to circle, because we're down to one term, right? My one term with my variable is 10x. So that's the last thing we're touching now. Add 6. Oh, sorry. That gives me +2 equals. This is 0, additive inverse. 10x comes down. How do I isolate the x? What do I need to do to isolate the x? Go ahead, Haley.
Divide by 10.
Divide by 10. That gives me x equals 2/10. Now, is that the answer? Yes, but it's not simplified. Some of you knew from Friday, oh, if I have 2 divided by 10, they're both even, I can divide by 2. That leaves me with 1/5. So a better answer is x equals 1/5. But holy moly, if you got to this part, I'm proud of you. Questions? Again, you will not see a problem like that on your quiz on Wednesday.